Okay, now with this big capacitor removed, we can see a lot more in here. A lot more. And I don't like I don't like what I'm seeing. Here, let's take another closer look and see what we can see. Well, starting right away with those molded capacitors. They look pretty good. There's a white capacitor there. Oh, I'm getting called by one of our cats here. You can hear it. Yeah. He wants to go in the room beside me. Ooh. Look at that. Cracked open, eh? That's the capacitor. Let me take my clip lead out of there. Now, I'm looking for, coming off the capacitor, is this red wire here. Pretty sure that's going to be carrying the B plus over this terminal. Huh. There's these little shielded cables here. They look to me like they're shielded. What about right back in there? Well, that's the plug to the back of the radio here for the speaker. Another crack on that, what I think is a resistor. Hunts. Now, didn't somebody say get rid of all Hunt capacitors, they're terrible? I think somebody said that. And that looks like a replacement to me. In fact, no facts. In guess. Oh man, look at it in there. Well, one thing's for sure. I don't think these capacitors are in here in some kind of positional. I don't think these capacitors need to be in exactly the position they're in. And I'm pretty sure when I replace a lot of these, they're going to have a lot more space, and they're all going to go into different positions. I don't think that's going to have any bearing on the radio's operation. Just because of their physical size and the opportunity to put them in different positions. And those big ones, like that big thing that was in here, not many options on where to put that. Wow. Okay, so now the question is, why no B plus further out into the set? That's really what's got me wondering what's going on. So let's try and trace the wire off the top of the capacitor. I think it's this one. Looks like I better think again. What is that down there? Okay, so that's where the wire goes. The red wire. What's under there? I can't even see through there. Crying out loud. I can't really see what's going on in there. Okay, let's take another close look. Right in there. Look, you can see the dirt on the high voltage wire. And I think it's right. See right down. Okay, see this resistor, this one dead center of the screen. You see its lead with some covering on it. Just beside that lead, down under, is the connector. It looks like it's another connector into this capacitor. And then what is this? What is this big? That is the connector. I don't know what I'm doing here. Unless there's two terminals on this capacitor and one of them is kind of tucked down there. It's not making sense. It's not making sense. Hey, I got the schematic. Let's refer to the schematic. Where's the schematic? Didn't I bring it in? Okay, let me fetch the schematic and study it a little bit. Okay, so here's the schematic here. And this is a hard to read schematic. It's written rather tight and crammed. A little bit like the radio itself. Let's see, power supply. There's a filter capacitor. There's another one up here. C31, C32. Look in the list. C31, 16 millifarad. C32, 18 millifarads. 450 volts. 16 millifarad is a 450 volt capacitor. Okay, so look again at the front here. See, I can read on it very clearly. 16 millivolt microfarad, 450 volts. So 16 is 31. Okay, so this is the one we're looking at right here. And now, why would no voltage get beyond this? No voltage. So where is this capacitor? So it's sitting right on the rectified output, and it's getting it's tricky to follow it. It's on either side of the center tap transformer, just as you would expect it to be. So this is the primary filter capacitor, or first filter capacitor. It runs up here and it goes up into the field coil. Field coil of the speaker. And I don't have the speaker plugged in. So that's why the B plus is going nowhere in the set. I have to plug the speaker in, so the field coil's in the circuit. The field coil of the speaker being part of the power supply filtering system and humbucking system too, usually. So I got to get the speaker. The speaker is screwed in the cabinet. I got to take it out of the cabinet, bring it in here, plug it in. We're going to have to use the, and I want to use the real speaker, not an alternative. And I don't want to do what I did a few radios ago and just skip the output transformer and hook up a speaker voice coil right across the output of the output tube. If you saw that video, that was interesting. Nothing bad happened, but doesn't sound like a good thing to do. I don't want to make that mistake again. So let's go get the real speaker and hook it up. Okay, so I have this speaker here that I've taken out of the cabinet. Here it is here. And I placed a put a piece of cardboard on it to protect it because I don't want the cone to be exposed. Because again, this is such an old radio. You really have to respect the fact that it's made it this far, and I don't want to be the guy who destroys some component of it. Now, I don't want to bend these wires too much. So this thing normally sits something like this. So I'm going to put it there. Try to plug it in here without too much bending. It certainly is bending a fair bit here. Let's see. There we go. Okay. Okay, so we have a speaker connected now. So that'll bring the voice coil into the circuit. And that's very interesting. You can unplug the speaker and limit the distribution of the B plus in the radio to just the power supply filtering system. And test that, just like I did, and then plug in the speaker and test more. Hey, how do you like that? A new technique. A new technique. Okay. So we should re-energize this radio. Now this big capacitor came out. Should we figure out where that came from? I think the answer is yeah. Let's just take a look and see what we removed here. I could still do B plus testing with a capacitor out. It won't make any difference. Or it shouldn't, unless the capacitor I took out was shorted. So, we're going to be able to figure this out quickly. If not, then we won't. I don't want to swing the radio around too much. Here. Oh boy. Where'd that capacitor come from again? I cut it off with a bit of wire sticking out, but there wasn't much wire. Okay, here we go again. Let's go take another close look. Now what I'm looking for is a little piece of wire left behind after I cut. Oh my, that's not it. It should be, it's right up in here somewhere. Looks like sunshine shining through those holes, but I guarantee you there's no sunshine here. Well, I don't see the wire. I see a lot of really crummy soldering stuff going on here. Wow. This was built in the 30s. You know, what were they using for soldering irons? I don't think they were using Weller temperature controlled soldering irons back then. I have lost sight of where that capacitor came from. I cannot spot the cutoff lead. Maybe it was up much higher. Maybe it was up in here. Can you see something in there? Holy smokes. I'm expecting to see a 1/4 inch little piece of wire just sticking out going nowhere. That'd be the remnants of the lead to the capacitor. But I see nothing. Look at that, look at that. These look really bad. They just look, ugh. That looks a little dark there. That could just be lighting effects. Well, no sign of the wire. So why worry about it for now? That's my point of view. Let's not get hung up on important things here. Okay. We are going to reconnect. Oops. We're going to reconnect the B plus. Okay, which is on standby still. Go right back onto here. This time when I turn the B plus up, we'll be pushing voltage, if I can put it that way, through the field coil and on into the rest of the radio. So we should see quite a different situation here. But what we did learn on the last test, hang on tight, gotta walk you through some wires here. We did learn on the last test that main capacitor is, looks like it's pretty good. So here we go. Voltage down, a good starting point. Voltage is applied. And here we go. And watch this current meter. If it just goes wild, we got a short in there. Here we go. Okay, should be seeing a raise. Yep, voltage going up. I see nothing. That's not right either. And everything is connected correctly. Let's get a closer look here. I'll jump the voltage a bit. Oh, did you see that? Funny, that was not me. I jumped the voltage up, and it went kind of up and down, kind of funny there. Okay, so now, see, I raised the voltage again, and now this time we've got a bit of a leakage current there. Where are we at on the meter? So we're probably putting about 100, a little better than 100 volts on it. And something is leaking. Something is leaking in there. Now it may not be important what's leaking. It may not be, it may be a resistor just bleeding a little current off somewhere. On the meter it's reading half a milliamp, and I think it's dropping. Half a milliamp's not very much, is it? And man, that's cold coffee. Ooh. Leave my coffee sitting. Yeah, it's very cold here again. It's about -5 outside right now. And we're coming up on around 11 o'clock in the morning. Well, let's go poking and see where this voltage got to. And I'm pretty sure it got quite a bit further along. Okay. Okay, so here's the actual supply voltage. It's 120, so we're putting 120 volts. And this thing's got to be ready to take closer to 300 or somewhere in that range, 350. If we put it up there right now, there might be consequences. So I don't want those consequences just yet. So, okay, any tube. Oh, there we are. Okay, so the B plus is getting through to this tube. This is one of the early RF tubes here. So that's a very good sign. Look at that, most of it's getting through here. And okay, so I think even just from doing that little bit, here's another one. We go down here and maybe I think the output tube is over here. Yeah, it's just buried, man. It's just buried under. Buried under a lot of stuff here. There we are. Okay, so that's a really bad looking capacitor. That's what we see on one side. And on the other side, we see a volt. So, you know, that could be leakage. Yeah, wow. Hard to believe. But the leakage has gone down. It's a little bit more. Maybe it's now it's well, let's compensate. We'll crank up the voltage here. Let's do that. Very large leakage current now, relatively speaking, but it's dropping. Well, now we're looking at, I was reading the milliamp scale wrong. 10. It's dropping towards 5 milliamps. Now, 5 milliamps at 200 volts That's 1 watt, I think. That's 1 watt of power. Hey, 1 watt of power. If that's all concentrated in one spot, something will get warm. Is that right? 1 watt? Or is it 0.1 watts? At 200 volts, and we're looking at 5 milliamps. I think that's 1 watt. It's very seldom that the schematic gives any information on current flow from the power supply. And this one doesn't say anything either about that. I have to study this for a long time to try to determine what the expected current might be, and I'm not about to do that. Son of a gun there. Easy as that. Let's go with the liar. That's what that meter's reading now. 225 or something like that, and you can see the current meter. It's not on 0 now. Okay, so I'm going to turn the voltage up. I'm just going to turn up a little bit, and you can watch what this meter does. Just a little bit here. Let me get both meters on view. Here we go. Okay, now I just turned that up another 10 to 15 volts, not much at all. You can see the and now the current's fairly significant. We're looking at 15 falling to 10. So it's falling to 10 milliamps. 10 milliamps. So it's a little higher than what I'm used to seeing. 10 milliamps. And what's our supply? We're at 250 volts and 10 milliamps. Two and a half watts, I think. 2.5 watts. This resistor right here is warming up. I can't move the radio around now because the speaker's connected to it. This big dog bone resistor, if I can call it that. He's heating up. Not much. And that's heating up. And where's that connected? Boy, oh boy. Yeah, that lets me lamenting about, how am I ever gonna... how am I ever gonna figure out where that goes? Yikes. Another possibility here, is to use the inherent power supply to fire up the tube heaters and continue to apply an external B+ and run the radio. I don't know if I've ever actually tried that before hooking up the power supply B+. Now the reason for this is as soon as the radio is feeding B+ voltage into the as soon as the power supply is feeding B+ voltage into the radio, the power supply is put at risk, and that power transformer goes at risk. And, I don't want to do that. I don't want to blow it. Not a hint of smoke anywhere. I don't think there's enough oomph here to really worry about smoke yet. You know, is that 2.5 watts on that resistor? Don't really think so. So something else is burning up some of this energy too. Oh my gosh. Really? It's pretty tempting to try hooking this right up, plug it right in and try it out. It's really, really tempting. I have to replace the capacitor I took out anyway. Hey, why don't we test that capacitor? At least I can test it for shorts and leakage easy enough. Now that's bigger than 20 ohms. Bigger than 20 megohms. Well, there's certainly no short in here. Now, you can see it charging up. So, chances are, this capacitor is still functioning. Working voltage, 1000 volts. What? No wonder it's so huge. 1000 volts. What would we ever want one that big for? There's no way there's 1000 volts in this receiver. Is the output voltage? I think I saw it somewhere here. Well, the rating on the capacitors in the power supply, 450 and 300. Now 450 is very high, and I doubt that this thing produces 450. It's probably more around 350. Huh. Well, this is a tough decision for me. Either we fire this guy up and start troubleshooting. Here, I just want to look at this capacitor here. Okay, I got a big lens and a camera in one hand here. That's why it's jerking around. Hold on here. How can I do this? I can't do this. What's that same capacitor I keep looking at with the whatever it is across it? Going to ground. Yeah. That's a tough decision. Where are we at now? The leakage current has fallen to 5 milliamps. And I think we still have pretty good voltage on there. $250. I have to think about the capacity of my power supply too. They can only sustain this kind of stuff for so long also. I can't decide what I should try. I just don't want to get in there and start changing all those capacitors left and right. Even the one I took out appears to have been okay. Seems to be supporting the B+ voltage I'm applying right now. I think we should give it a go. Let's do that. Let's give it a go.